Let's continue looking at addition of vectors. Last time we looked at this, we were adding vectors that were pointing in the same direction or in opposite direction. And when they pointed in the same direction, we simply added them. When they pointed in opposite direction, one was positive and the other was considered negative. And we added a negative. So in other words, we subtracted one from the other. Now, we also were looking at a certain situation. We're saying, what if, say you were upstairs looking down and you saw this table and somebody was here pushing the table in this direction with a force of 70 newtons. And the other person was here also pushing the table in this direction with a force 90 degrees to the 70, and that force was 60 newtons. How do you add these? Well, you can't just add them directly like how you add numbers. Now this is what you have to do. You take the 60 newtons. Let me transfer it over here. This is the 60 newtons. Let me use 1 centimeter to represent 1 unit. It's 1, 2, 3, 4, 5, 6. 1 centimeter to represent 10 units. So that 6 centimeters would be 60. 6 times 10, 60 newtons. Alright? So this is our 60 newtons. Then the 70 newtons. What you do is put it in such a way that the end of the 60 is pointing to the beginning of the 70. So you have 1, 2, 3, 4, 5, 6, 7 centimeters. That's lean. Let me do it again. 1, 2, 3, 4, 5, 6, 7. Okay, good. 7 centimeters to the right. Now, this is our 70 Newton force. All right, let's look back at this. Question. In which direction would the table move? Well, if you're pushing up this way and this way, it's going to move somewhere between the direction of the 60 and the 70. Somewhere within this direction, right? But because you're going to have a combination of movement in this direction and movement in this direction. So they're going to be combined somewhat to move somewhere within this region. Now, let us join the ends of these two vectors. Let's use a straight line. All right. Now, the table, as we saw, would move somewhere in this direction. Let's put 2 arrows on it, because a combination of 2 forces. So you can see here that if you should draw the 60 in the same direction here and then draw 70 and join them up, what you would have is really your answer. So what was done here is that the 60 Newton vector was added to the 70 Newton vector. And we have this green one with the 2 arrows as the answer. Now this answer is some when you add 2 vectors and you get an answer, which is a third vector, this is called the resultant vector, or sometimes it's just referred to as the resultant. It's just like when you add 2 numbers, what you get, you call it the sum. When you add 2 vectors, what you get, you call it the resultant. All right? Now notice here that we had these two vectors, the 60 and the 70, and then we had the third vector closing what is really a triangle. Now this comes in where we want to give a name to this method. This is called the triangle rule, or the triangle law of adding two vectors. What it says is that when you add two vectors, join them so that the end of one vector touches the beginning of the other. These will be two sides of a triangle. Then close it with a third side. That third side that closes the triangle is the answer, which we call the resultant. The resultant must oppose, the direction of the resultant must oppose the other two vectors going around the triangle. Now what does that mean? What it means is, say you're walking around the triangle, alright? Say this is you, and you want to walk all the way around the triangle. Let me get you well set. I want to set you up quite well here. So this is you. I want to combine everything that I have here for you. And then you're here and you are this way following the 60, then you are this way following the 70. Now, when you're walking around the triangle and you're going this way, you're being opposed by the arrows of the resultant. So remember, you're following the arrows, the direction of the arrows on the two vectors you're adding. But when you're coming this way now to walk around the triangle, you're being opposed by the arrows on the resultant. So that's a triangle law. Alright? So let me make a note of that. We're using the triangle law of adding vectors. So the two vectors you're adding, you make them touch. The end of one touches the beginning of the other. Then you draw a third vector to close a triangle. You form a closed triangle. The direction of that third vector is the direction of the resultant, and the magnitude of that third vector is the magnitude of the resultant, which is the resultant is what you get when you add two vectors. Good. Now, let us consider these two vectors again, right? The 60 and the 70 newtons. If I should draw the 60 newtons going this way, say 1, 2, 3, 4, 5, 6, and you draw the 70 newtons. First of all, this is the 60 newtons, alright? So let me label it. Then the 70 newtons going this way, 1, 2, 3, 4, 5, 6, 7. So that's our 70 Newton vector. The thing is this now, how do you get the resultant? In this case, when you draw them touching, so that the beginning of each vector touch each other. Suppose you draw another vector like this. So you draw it 1, 2, 3, 4, 5, 6. The 60 newtons. You draw it going upwards. In other words, you draw the same vector again. Then the 70 newtons, you draw from here. 1, 2, 3, 4, 5, 6, 7. So this is your 70 Newton vector. So remember, this 70 Newton is the same vector. This vector for 60 Newton is the same vector. What you do now is draw a diagonal in such a way that the diagonal is projected from where both vectors leave and then ends up where both vectors end. So this now is your diagonal. That is your diagonal. Notice what happened now. This diagonal is the same as this. And the shape that you have here is not a triangle anymore. It's really a parallelogram. And then the resultant is one of the diagonals of that parallelogram. Alright? So, this one now is the parallelogram law. Is a parallelogram law of adding vectors. So you have these two main laws, the triangle law and the parallelogram law. We're going to use both of them in later examples to add two vectors. Alright? Of course, if we have several vectors to add, you just add two at a time. So I can safely say to add two vectors. So, in this case, this vector is your resultant, and it's the same resultant as this. Because this 60 newtons is the same as this 60 newtons, same magnitude, same direction. This 70 newtons, which is also this, is the same as this 70 newtons. Same magnitude, same direction. And then you draw the third side to close the triangle in the triangle law. And you draw the diagonal of the parallelogram here, which is the resultant vector. Alright? So, that's how you add two vectors together when they are not pointing in the same or opposite direction. You use the parallelogram law or you use the triangle law.